Hi guys, so we are back and we are solving the fourth problem. If you are still there, thank you very much. If not, then how would you know? Anyway, so we are gonna solve this, but this does not involve the Atwood's machine. It's a different setup, but still involves friction. An 18-kilogram box is released on a 33-degree inclined plane and accelerates at 0.300 meters per second squared. What is the coefficient of friction? So first, you need to draw the diagram. This is not to scale. This is 33 degrees, and this you need to have the free body diagram first so you can set up a solution for that. So this is the gravitational force, which is directly downwards, and this is gonna be the normal force that is perpendicular to the plane. Notice, class, that you might be thinking, sir, it's not really straight line. I'm really sorry because how I wish that I could make it straight, but when you're writing in an electronic tablet, it cannot easily be controlled. So sometimes I'm just guessing where it is. So this is the normal force, and with that we can have this. However, we have 33 degrees as an angle here, so we need to make sure that we have the components for the x and y of the gravitational force. So this is the component of this. I'm sorry, it's not so straight. Okay, anyway, so give me 1 second. All right, so yeah, there you go. So this should be like, oh my gosh, it's not following. It's not following what I want. Okay, next. Okay, that's much better. And I believe that you already know the diagram. So this is gonna be FGY, and this is gonna be FGX. All right. With that, we can have, if basic geometry would tell you that if this is 30 degrees, then that means that it is also 33 degrees. Okay, if this is 30 degrees, or if this is the theta, then that means FGY will be the adjacent and FGX will be the opposite. So having said that, we can have FGX is equal to mg sine theta, and FGY is equal to mg cosine theta. Okay, next, so basically we have this is 18, yes, 18 times 9.8 times sine 33, and the answer for that one is 96.1. This is the component for the x-axis, and this one will be given 18 times 9.8 cosine 33. So the answer for this is equal to 148. All right, that's great. Now, we need to get the summation of the forces along y and along x. So we have the summation of forces along y is equal to, this is okay, is equal to MAY. All right, great. But so with this, we can have normal force minus FGY is equal to, you notice here that there is no acceleration because it's not moving along the y-axis. So this is equal to 0. So that means I already know FGY, which is 148. So that means that the normal force here is 148 newtons. We will use that later. And we have now the summation of forces along x. So that means we have the summation of forces along X is equal to MAX. Alright. For the forces along Y, it's already complete, but we are lacking something. We are lacking the friction. Remember that there is a coefficient here, so we already know that there is a friction. So the summation of forces here is, it really is up to you whatever reference you're going to use, but I am going to use the reference for acceleration as the positive one. So with this, I can have Fgx minus the friction is equal to max. You notice that, yes, I understand that my orientation a while ago is like, if it's right, it's positive, if it's left, it's negative. But then again, with this, if you're going to use that, it's just okay, because what will happen is that if you will use this as negative, then this, then if you use this as negative and this is positive, and since it's going here to the left, this is negative, so it's just a variation. So variation of the directions, but then again, it's just the same. If you transpose it, it's just gonna be equal to this. So there, I already have FGX. FGX is 96.1. Give me 1 second. All right, 96. Okay, it's acting up. Sorry. So I have the eraser. Okay, sorry, I'm not perfect in doing this. 96.1 minus friction is equal to, the mass is 18 and the acceleration is 0.3. So with this, I can determine that the friction is equal to 90.7 newtons. However, you already know that the friction is equal to the mu n, but I already, in this case, n is not just equal to mg. You know that a while ago we have gotten that, and Fn is equal to this one, which is equal to Fgy, which is equal to 148. So with that, we can have friction is equal to, no, sorry. Okay, there you go. So the friction is equal to already 90.7 is equal to the mu times 148. Divide both sides by 148. You will lose the unit. So mu will be equal to 0.613. That's it.